In this video, we're going to solve quadratic equations using the square root property. Anytime you have x squared equal to a number, to solve for x, all you have to do is square root the number. But when you do it, instead of having one possible solution, you'll have two, a positive and a negative. So for example, if you have x squared equals 25, to solve that, you would square root both sides because the opposite of squaring is square root. And here it becomes positive or negative square root of 25. Now when you square root a square, it cancels out the square. So you're just left with x, and here we have positive or negative. The square root of 25 is 5. Now, the reason you have two possible answers is because both positive 5 and negative 5 squared will give you 25. So for example, if we did 5 squared, 5 times 5 is 25, so that works. And if we did negative 5 squared, negative 5 times negative 5 equals 25, so that works. So you can have two possible solutions when you're solving for x squared. Now, sometimes when you're solving for x squared, you'll have it equal to a negative, and we know we can't square root a negative. So remember, we learned earlier that you can use I as a placeholder for the square root of negative 1. So for example, we're doing x squared equals negative 81, and we wanted to solve that. We would square root both sides. Again, the other side, I get positive or negative, square root of negative 81. So x is equal to positive or negative square root of negative 81. Here I get stuck because I can't root a negative, so I'm going to rewrite it a little bit different. I can rewrite square root of negative 81 as 81 times negative 1. And then what I can do is I can actually split it into two different roots. Square root of 81 times square root of negative 1. I know the square root of 81 is 9, and I know the square root of negative 1 is I. So this is really positive or negative 9i, which is two separate answers, 9i and negative 9i. So if you have a negative when you root it, you'll get the same number. So like the square root of 81 is 9. But instead of just doing 9, you can write an I to represent that it was a negative root. So we're going to solve some problems here. Again, this method only works when you can get x squared by itself. If there's an x in the problem other than the x squared, you're not going to be able to use this method. So here we have x squared equals 121. If I want to solve, I'm going to square root both sides. So I get positive or negative root 121. So x is equal to positive or negative 11. Really, that means you have two answers, x equals 11 and x equals negative 11. Our next one, we need to get the x squared by itself. So here to get x squared by itself, I'm going to do minus 4 to both sides. And then I get x squared equals positive 81. Now I can square root both sides. When I square root both sides, I get positive or negative root 81. So x is equal to positive or negative 9. On the next problem, we need to get the a squared by itself. So I'm going to start by moving things to the other side. So here the 6 is canceled. I have 10a squared equals 0. Next, I could divide by 10. So I get a squared equals 0. So my next step would be to square root both sides. Square root of a squared equals positive or negative root 0. So a equals positive or negative 0. There's no such thing as positive or negative 0. For this one, we really only have one solution, which is 0. On our next problem, the x squared is already by itself. So we just need to square root both sides. Here it's negative 25. So like we learned before, you can actually split this into 25 times negative 1 and then do square root of 25 times square root of negative 1. We don't have to do all these steps though. Just because it's negative, that means our solution is going to be imaginary instead of real. So square root of 25 is 5, but because it was negative, I have to put that I at the end. Next, I'm going to get x squared by itself. I'm going to add 10 to both sides. So I have x squared equals negative 4. And now I can square root both sides. So I have x equals positive or negative. The square root of negative 4 is going to be 2i. So square root of positive 4 would be 2. Square root of negative 4 is 2i. Now we look at our last problem here. I'm going to do the same steps. I'm going to try to get b by itself. So I need to undo the 3 first. So I get 2b squared equals negative 18. And then I can divide both sides by 2. So I get b squared equals negative 9. Now I can take the square root of both sides. So when you do square root of 9, it would be 3, but since it's square root of negative 9, it's 3i. So b could equal positive or negative 3i. Your solutions here, the ones that have the i's that are imaginary, if you were to use the graph method, you wouldn't see them. You would see no solutions, no x-intercepts. So the graph method wouldn't work for this. Same with factoring. When you factor, you're not able to see your imaginary solutions because those are the problems that are not factorable. However, if you do use the square root method, you're able to see those solutions. It's just we're using I to represent that they're imaginary. They're roots of negative numbers.